All right, here we go. So we're on 1.1F, exponential functions and percent change, okay? By show of hands, who loves word problems? Okay, we got one. We got a little shimmy. Combined, they make one because they both went like this, okay? Yay for word problems, because that's what we're working on for the next 2 days, okay? So remember, while working on word problems, reading is fundamental. You must read the problem, okay? So we're going to start off here. We are talking about exponentials. So at the top, we're going to write our exponential rules. So we have y equals a times b to the x. That's our exponential function. Agreed? Yeah, we've been talking about it for a while now. In word problems, we're going to identify what a and b generally means in a word problem, okay? Your a is generally going to be your initial value. Okay, your a is going to typically be your what? Your initial value. Your b is what we call your percent change. Not your percent change, your growth factor. I lied. Don't write that. Growth factor. You saw nothing. You have to use your percent change. Okay? Your growth factor. Okay? Now, how do you find your growth factor, you ask? You have to know your percent change. Okay? So to find, we're going to write right here, our growth factor is equals 100% plus or minus our percent change. Okay, so when we're talking about our percent change, this right here, this guy, you're asking, what are you increasing or decreasing by, right? It's the value that you increase or decrease by. Okay, when we're reading word problems, this is where that math and common sense comes together. Okay. All right, let's read about Sandy. As we're reading about Sandy, we're going to mark the text. Do y'all remember marking the text in English? Did you know you could apply that in math? Yeah. When we mark the text, we want to underline or circle. Well, I typically circle key information and I underline what it's asking of me. Does that make sense? Okay, so Sandy collected 10 pounds of apples at an apple orchard. She is determined to eat 20% of the apples remaining every day after the day she went to the orchard. Write an exponential function to model the scenario and use it to estimate how many pounds of apples she has left after 1 week. Okay, so as far as marking the text, to me, 10 pounds seems like it's an important detail, right? She's eating 20%. And it wants me to find a exponential model. And it wants me to figure out how much she has left after 1 week. After I mark the text, I'm going to see how what I marked applies to my model, right? So now we've marked our text, and we're going to look and see how does this apply to our model. So I need to know A, initial value, and B, growth factor. So A, what out of what I've circled, what is my A? 10, the 10 pounds. That's the initial amount. Agree? Okay. My growth factor. So my B is going to be my growth factor. But in order to find my growth factor, I need to know the what? My percent change. So what is my PC? What is my percent change? 20%. Is it an increase or a decrease? It's a decrease because she is eating. So it's going to be a negative 20%. Does that make sense? Okay, the next thing we need to know is what is our growth factor? Well, I can find that now, right? My B, my growth factor is 100% plus or minus my percent change. So for this problem, it's going to be 100% minus 20% because I am decreasing, I'm eating, right? So what is my B? 80%. How do I write that as a decimal? 0.8, 8/10. Do I have all the parts to write my equation? Yes. And what is my equation? Y equals 10. Y equals 2 to the x power. So there's my equation. So the first thing it said to find is write your exponential function. Did I do that part? Yes, that piece is done. The next thing we underline, it asks us how much would she have left after 1 week, right? So when we read this problem, we know that this is in terms of days, right? X is days. And so if after 1 week, my X is going to be what? We're looking for X equals what? 7. 1 week means that X equals 7 days. And if I have my X value, all I have to do is what? Solve, plug in and go, right? So we have Y equals 10 times 8/10 to the 7th power. When I plug that in the calculator, approximately how much will she have left? Nearest 10. 2 1/10 of a pounds. And you make sure you put your units. How do we feel? Doable? Okay. So this was given where we had the words, well, not the words, we were given the numbers, we had to create the function. What I'm going to give you to do, because if you can work backwards, that means you understand what's happening. So on your example number 2 in your notes, you guys are going to work backwards. You're going to take apart the function. So you're going to tell me what was my growth factor, what was my percent change, what was my initial after you read and go through the problem. Okay. All right. Is 2 minutes fair? We'll see where we're at in 2 minutes. Great. All right, we'll check back in. So at your table, you're reading and you're going to figure out Jenny's initial values. Go. All right, so Jenny is running a simulation to track the spread of common cold. Her simulation uses an exponential function to model the number of people with the common cold. The simulation resulted in P of T equals 3 times 1.25 to the T, where P of T is the number of people with the common cold and T is the number of days. What is the initial number of people? So we're looking for initial number of people with Jenny's with the common cold and Jenny's simulation. What is the growth factor of the number of people with the common cold? And what is the percent change? Okay, so those are the 3 things we were looking for, correct? All right, so what did you guys get for your initial? Perfect. 3 people. And that's because your initial is always your A value. Got it? Okay. Next, we're going to talk about our growth factor. What did you get for your growth factor, your B variable? 1.25. That's our growth factor. From our growth factor, what did you get for your percent change? Oh, look at y'all geniuses. 25%. Yes? All right. So we really know what we're doing. Beautiful. We're teaching, guys. We're learning. All right. Rohiza sold her stamp collection and every year thereafter donates 30% of the remainder of this money to charity. If her stamp collection sold for $6,000, how much of the initial amount will she have after 2 years? Okay. So we're going to mark the text. We have 30%. That's important. We have, and she's donating 30%. She sold and earned how much? 6,000. And it wants us to, how much of the initial amount will she have after 2 years? When this is asking here, this is just asking for your model. What is your function? That's because if they give us a value for T, no. So when there's not a value given, all they're asked, that means all they want is the model of the function. All right. Okay. So tell me, what's my A? 6,000. A is my 6,000. Good job. What is my B? Oh no, 70%. 70%. And why is it 70%? You take it from 100. My B is going to be that 100% minus 30. And we're subtracting because she's doing what with the money? Donating. So B equals 70%, which is 0.7. Can I easily now write my? Yeah. I can. What is my function model? It will be 6,000 parentheses 0.7 to the T. To the T. Good job. Yes, we're geniuses. Okay. Yeah. Not terrible. See, look, guys, word problems aren't that bad. We're not there. Can't just skip over E. All right, so here you go. Your hint for this problem as your table. When you are counting, how many of y'all make the bad habit of counting the day you're at as part of your days? So like, when you're counting, like let's say, oh, it's 10 days to my birthday. Do you count day 1, like being the day you're on, or do you count 10 days from that day? It's actually afterwards, but you have to subtract. So like the day you're on doesn't count. So I'm not going to say, oh, my birthday's in 10 days. And today being Wednesday isn't day 1. Day 1 of me counting to my birthday is tomorrow, the day after. That's 24 hours. So keep that in mind when doing this problem. Got it? Yeah? That's your hint for this problem. All right, so we have here Peter. Peter is growing. He's trying to be a social media influencer, I see. So he posts. He gets 45 likes on the first day. He's starting off slow, I see, of a particular month. And then the total number of likes increases about 15% every day. Write an exponential function model for the scenario and use it to estimate the number of likes Peter would have on the 25th day of the month. Okay. So marking the text, we have he receives 45. It increases by 15%. And I'm looking for an exponential model. And I want to know what's happening on the 25th day, right? What is my A value? 45. What is my B value? 1.15, right? Okay. So my equation is going to be 1.5 powered by 25. All right. So that you remember what you're doing, remember it's always minus when you're counting from a day, it's going to be the x minus 1. Okay. If you don't remember that, that's why you write the equation like that, because it forces you to remember to subtract that day. Does that make sense? It's like, okay, here's my reminder that I do not count the day that I started. Okay. So when we do it, y equals 45. So even if I do use 25, when I do the math, what is it going to make me do? Subtract that day. It's a built-in caution. Does that make sense? It's like, ooh, safety net. Subtract 1. Okay. So anytime you're counting from a day, think about it like that. Unless they say 0 is your beginning, you're starting on day 1 and you got to be mindful of where everything else is going. Okay. All right. So what did we get? How many likes? 1288. Well, you got 0.13 likes? Yeah. I don't think that works. All right. So his account is growing. I've never had that many likes on anything. So to me, I feel like he's a rock star. I've never had that many likes. So good job, Peter. He's moving up there. All right. Okay. So the last one is going to be your do now for tomorrow. But if you want to get a head start on it, by all means, you can. But you're going to be posting it for tomorrow. Yeah, that's it for today. How do we feel? Good?